Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 28, 2025, just 2 days ago. The standout idea is proof of transit timestamping, a transport-level receipt that chains per-hop custody attestations to payload hashes, so interplanetary Bitcoin traffic gains tamper-evident, time-anchored audit trails without changing the base layer. The paper is titled Bitcoin as an Interplanetary Monetary Standard with Proof of Transit Timestamping, and the implications for cross-planet commerce are quite significant. In brief, the work pairs header-first replication, latency-aware lightning policies, and federated or blind merge mined commit chains to enable practical Earth and Mars settlement. On X, reactions tie interplanetary Bitcoin to pop finance narratives, with posts hyping Mars-themed futures, corporate accumulation stats, and a video tagline about a station, while one researcher links the ARC's 14 release. Engagement ranges from modest to over 11,000 likes. Alright, the previous figure set the big picture for interplanetary operations. Figure 2 illustrates how proof of transit timestamping works end-to-end, as a bundle travels from an originator through relays A, B, and C to a recipient. Each relay emits a signed receipt that binds the payload hash, the relay identity, and ingress and egress times, so the receipts concatenate into a chain of custody. The recipient verifies signatures, checks identical payload hashes and monotonic timing, and then attaches the verified chain to lightning disputes or sidechain peg withdrawals. So, while the previous figure framed the end-to-end receipts, Figure 1 presents the system layout that ties networks on Earth and Mars through a deep space delay-tolerant link. The diagram shows header-first replication flowing over the DTN deep space link with proof of transit receipts, while each planet maintains its own Bitcoin and Lightning cluster. The top satellites represent optical relay meshes that carry bundles along DTN custody paths. Settlement occurs asynchronously through federations or blind merge mined commit chains, which keeps the Earth base layer unchanged. Alright, the previous figure highlighted the network layout. Table 1 lists the core symbols that drive timing and verification, which matter because time locks must absorb interplanetary delay. The table defines one-way, light time, and round-trip time, the additional time lock blocks for latency, and the operator and operational margins that sum to the recommended lightning time lock. The entries also specify timestamp encoding in TAI seconds, authorized relay identities, nonces, payload hashes, and bounds for safety, clock uncertainty, and median time past skew. Okay. The previous table defined the symbols and timing knobs. Figure 3 shows how extra lightning time lock blocks rise with one-way light time, with separate step curves for 0, 30, and 60 minutes of jitter. The staircase shape appears because the additional blocks increase only when round-trip time plus jitter crosses multiples of the 10-minute block target. The plot makes the policy concrete. A Mars window near 22 minutes one-way implies roughly 5 extra blocks at 0 jitter and about 11 with 60 minutes of jitter. So, the previous plot quantified time locks. Figure 4 maps the full stack, which places proof of transit receipts in the transport metadata, while higher layers simply consume them. The bottom transport band carries bundles across optical meshes and deep space delay-tolerant links, and the adjacent receipt band appends per-hop signatures and times. Bitcoin peer-to-peer then delivers headers, filters, and transactions, while Lightning and Watchtowers attach and verify receipts for channel messages. Settlement rails require receipts for peg in and peg out, and operations and security archive disputes and verify time beacons. So the previous figure placed receipts within the full stack. Table 2 outlines the POTTM2 verification profile, which sets enforceable rules for watchtowers and federations. The table requires at least 3 receipts across 2 operator domains with separate time anchors on Earth and Mars, and it bounds per hop timing by jitter and the current one-way light time envelope. High-stakes cases demand 2 path-diverse chains, authorized relay keys on an allow list, a cap of 32 hops or 8 kilobytes, and at least 90 days of retention. Wrapping up, 2 takeaways stand out. Proof of transit timestamping adds tamper-evident, per-hop timing to Bitcoin traffic, and the stack keeps the Earth base layer untouched by shifting complexity to transport, lightning policy, and settlement rails. The broader implication is practical cross-planet commerce, with auditable delays, not consensus changes. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.